Hi everyone. In the last lecture series, we have seen serial communication interface. In this lecture series, we are going to see the parallel communication interface. So this parallel communication interface is an I/O port chip. It is used to interface the I/O devices with the microprocessor system, and it is used to implement the parallel data transfer between the processor and the devices. So the devices may be ADC or DAC, 7 segment, whatever it may be. It is a programmable device and it consists of 24 I/O programmable pins, and it consists of 4 ports. Each ports have 8 pins. Here A and B are called as parallel ports, and port C is split into port C lower, another one is port C upper. So totally it consists of 24 pins. Apart from that, it divides the two groups that can be programmed into 3 different modes. One is mode 0, mode 1, mode 2, simple IO port, handshake IO port, another one is bidirectional. So here in this mode 0, port A and port B, that is used as the 2-bit ports, and port C here we are using as 2 4-bit ports. It can be programmed either in output mode or input mode. They do not have the interrupt capability. So it has to interface with the hexa keypad or the 7 segment. So here what do you mean by this mode 1, that is input output with handshake. So what do you mean by handshaking? Means input or output is transferred by the handshaking signals. It is used to transfer the data between whose data transfer is not same. The computer send the data to the printer large speed compared to the printer. When the computer send the data according to the printer, that time only the printer can accept. If the printer is not ready to accept the data, after sending the data bus, computer uses another handshaking signal to tell printer that valid data is available on the data bus. So here these lines can be used as the handshake signals. So here in this mode, that port A can be configured as the bidirectional port, and port B that can be used in mode 0 or mode 1. So here we are having 5 signals that can be used for the data transfer. The remaining signals can be used as either IO or handshake for port B. At the same time, the bidirectional data transfer that has been allowed to this mode, so it is only possible for the group A. Port C, it consists of 2 ports, that is one is upper, another one is lower. It is used for the handshaking mode. So this is a pin diagram of 8255. It consists of 40 pins, where data bus buffer consists of D0 to D7, and we are having 3 ports, port A, port B, port C. Each port consists of 8 pins. Totally we are having 24. So 24 plus 8 pins, we are having 32. Apart from that, we are having supply, another one is ground. So here we are having the read write logic. In that read write logic, we are having read write, reset, chip select A1, another one will be A0. So this is the next thing, we are going to see the block diagram. So before that, the data bus, it is a bidirectional bus. It is used to connect data for transferring. The chip select, it is an active low signal. It enables or inputs the low signal on this, selects the input and to enable the communication. Read, it is an active low signal. The microprocessor reads the data. At the same time, if it is write, it means to clear the control register. PA0 to PA7, it is a bidirectional IO pins. PB0 to PB7, it is similar to the port A. Here PC0 to PC7, it is also 8-bit bidirectional IO pins. It is divided into 2 groups, that is PC0 to PC3, that is lower groups. PC4 to PC7, it will be higher groups. So this is the block diagram of the 8255. So here it has been connected to that of the 8-bit internal data bus. We are having the data bus buffer. It consists of 8 pins D0 to D7. And it is connected to that of the group control. So it is bidirectional. It is used to transmit and receive the data. Apart from that, the read write control logic has been connected to the data bus buffer. where it reads and writes the data, and the chip select, it is an active low signal. Apart from that, we are having the reset devices. These are all connected to that of the two types of the control, that is group A, another one is group B. Group A control consists of two blocks, group A port A, another one is group A port C upper. So it consists of 8 pins, that is PA0 to PA7. It is also bidirectional. In port C, it consists of 4 upper ports, that is PC7 to PC4. In group B control, it consists of two blocks. One is PC lower, another one is PC, that is port B control. So it also consists of 8 pins, and the remaining port C lower, it consists of 4 pins. So all the data that has been connected with the modes of operation, the communication between the internal data bus and the buffers. So we are having group A and group B. The purpose of the group A and group B, get the control signal from the CPU and it sends the command to the individual control box. At the same time, group A and group B, that will be control the signal of both port C's upper and lower. It is a buffered IO latch, and it can be programmed by mode 0, mode 1, another one is mode 2. So apart from that, we are having two modes of operation. One is MSW BSR, that is bit set reset. Another one is IO mode. So both the control words are written in the same control register. Thank you.